And now we have time for questions. I hope there will be any questions. So I will just, yes, please go to sit down. I will just quickly remind you that our first speaker, sitting here on my right, Risto Kossonen, he spoke about demand-side flexibility in buildings, about how to actually serve how to save energy and money using flexibility of energy prices, and in future also flexibility in district heating prices. And he showed us 3 examples of that. Then we had here Heikki Ihasalo. He was speaking about machine learning in smart buildings operation, and what are the applicabilities of machine learning in buildings on different levels of actually like people and systems and or buildings. Then we had the presentation of Henry Usler, which was about lighting networks providing new data insights for smart buildings. And he was speaking about actually why should we control lighting and what we can actually gain. And the last speaker you just heard was Peter Paus about how to get from connected to automated buildings. So actually I would then start myself. First question actually to Risto Kossonen. You spoke about that these prices, using prices for flexibility in energy district heating. You showed 3 examples, 2 different buildings, and one, actually the last one was community. My question is, actually, is this already used in Finland, or were these examples you showed where they're like sort of living labs, or is this already happening in Finland?
Yes, thank you for question. Really, it is the one case I saw in this large building complex is really what I presented. They changed their control strategy for base of the price, so that is really ongoing the case. And also this small energy community is the same. It's by the way, it's our university campus is that community, and we have made a lot of modeling and measurements of this field, so that is really alive. So I can see in practice that we have a lot of interest for this kind of applications. So where we merge together with heat pumps and district heating, that's the main heating system in the Nordic conditions, and also utilizing the possible waste heat there, like supermarkets or data centers or process heating, like what we have it there, the university campus. So really, they are alive.
Okay, good to know. Are there questions from audience to Risto? There is one.
Maybe a little bit connected to this, because you spoke about, or several people spoke about smart readiness. And I heard mostly it's about the buildings and systems, but I wonder about your opinion about the smart readiness of the organization. For example, about facility managers. Do they need retraining, or does it need to involve a separate company to actually implement and run things? What's your opinion about this?
Maybe I can start, maybe colleague can continue the same question, but it's what I presented, this SRI is a really European level scheme to measure smartness. But yeah, you are right, because we have some other bottlenecks here, because I think one thing is that the systems are becoming more complex, and they require the skills which maybe our maintenance staff or even designers, they don't have it when we're designing very complex system. you have to be guaranteed that this working as a design in all the cases, and it needs a lot of work in the commissioning phase. And absolutely, when we are running those buildings, then we have a collected data and analyze. So I have seen in the many buildings where is implemented this complex heat pump system, for example, nobody have really monitoring though that they are working as designed. And heat pumps are very sensitive for minor errors there, like the temperature levels are like that. And it's possible that we don't get out for the benefits what we are aiming to have it there. But maybe Heikki can continue for your side.
Agree with Risto. The systems are getting more complex. It's like more difficult to maintain them, and it's a challenge for the maintenance personnel. Absolutely. Perhaps this kind of like a fault detection and diagnostic systems could help them in like finding the situations when we have problems, and also finding the causes behind the faults, and believe that we will have more like an like centralized experts that then will support the local maintenance men in like an operating the systems in the future. Yeah.
Okay, then
I
Peter.
might also add a couple of things. So I didn't say anything about smart readiness in the presentation, but we do have some work on the smart readiness indicator in the Netherlands. And when you listen to the companies who want to implement it, I think they can step by step they go along, and they have they use typically these draft schemas to say, okay, what can we improve in our building, looking at the indicators of the SRI, and then and it says we can improve it this way and this way and this way. But it's very important to also connect this with correct goals. So that's what they say. So it's one thing to make it smarter, but the other question is then what are we actually gaining with making it smarter? There should be a point, and that often they often connect that to the Paris Agreement basically, because that gives them value. So I think because that's what the clients basically then want. So I think if the value is there, and then you have a mechanism that that you take along the people of your organization step by step, then we should get there. We will still need all of the engineers. Yeah, really.
Yeah, and maybe one specific thing, I think you were mentioning also these smart grid integrations. So I think in that area, it might be indeed that it's not enough just to educate facility managers and have new designs. There might be space for new type of companies who are just focusing on these integrations, at least at the beginning.
Maybe I added one thing, that it's giving new business models there, that new, like energy side, there's coming aggregators. Like my last case is that there is an energy community. In fact, there's an energy company who is running the whole system there, and they are selling energy as a service. So that then there is high interest that system is working as it should be there. So it's giving new business models for that point of view. We needed somebody who is really responsibility of those things.
Okay, thank you. Then I would go further with a question for Henry about lighting. Actually, you said at the beginning why we actually use lighting control. You said that can improve well-being, increase flexibility, or save energy. So actually, my question is, for which of these reasons is the mostly used? Why for is lighting control in practice used the most, and can you combine it though?
I think it's first of all, I think nobody install lighting just for energy saving, because at the end lighting anyway use energy. Of course you can then so lighting design should always start from needs. So in that sense, well-being and effectiveness. So what is needed for people in that place. So in that sense, well-being and productivity and that type of things, they are the most important. But then basically you could do the lighting which would support, at least if task in the space remains same, you could do the lighting that it's just static, it's always on, it's always like that. and it's quite okay. So lighting control point of view, quite often important is actually this flexibility and energy saving, that you don't need to maintain these maximum levels all the time, because anyway artificial light, if we compare indoor and outdoor conditions, we are in kind of darkness all the time here at indoor compared to levels what we have outdoor, which is basically the level during this human evolution we are used and how our physiology works.
Okay, thank you. Well, then, actually, I noticed in your presentations that there was some, I would say argument. Actually, Heikki, you spoke about smart buildings, operation, machine learning, lots of sensors. And then Henry, he said, who less sensors, who better combine. And then Peter came, and it was about sensors and connecting and everything. So, if you don't hear it, what is better? Maybe then start with Peter, the last one. Here.
Yeah, it's a very good question, and I will not have the full answer to that one. I understand both points. If you have plenty of sensors in a building and you end up not knowing which sensor you have, then it's a waste. Then you're sensing the wrong things. You should place sensors where you need them, I think, first. So I would also argue for being smart about where you place your sensors, and then maybe place a few less and do good control. On the other hand, I also think that in the future we will just have more, we will anyway be more connected, so it will gradually not matter a bit less. I don't know. Yeah, that's my reply.
And Henry?
Yeah, of course, I think I'm right, but I think that, indeed I agree with others. I think it's not really. You have to think what is needed. It's similar way like with this lighting thing. It's, like previous answer I gave that related these lighting needs. Start with the needs. So if you design a building, and I think it's if you manage to do that with less sensors, then you should do that with the less sensors. But on the other hand, if you need more sensors, more senses in that sense, because you might need a special sensor measuring whatever humidity at certain place, etc. There's I think there's sense to add those, but it's always before adding sensors top to each other and adding several sensors networks. It's good to think that why you are doing it and where you need that.
And perhaps we could share the information between the sensors. For example, the passive infrared sensor is used for lighting, for ventilation, for security systems. Why do we install 3 same kind of sensors to the same room? So there's no sense in that. So like sharing the information between systems would be beneficial.
I added here one element here is the quality of the data is very important, that we have to be tested that this really the data is correct, because we have many buildings that we have collected data which is not even correct, and that's a big issue. And then other thing, even we have the data, then how we utilize the data, that's we have a lot of things to do it even for existing system, that we really can use the data for monitoring and checking and fault diagnosis and whatever the purposes is needed.
Okay, thank you. Well, then I have more question for Peter Paus. Actually, you were sort of like promoting in your presentation, then actually we should go to like this, all these data about buildings should be web-based, should be actually put more on internet. Is that not dangerous? I'm not that expert. Is that not dangerous? These films like people then take over whole building, everything. How is that safe?
Yes. Yeah. Well, many things are.
Yes.
Many
Is it
things
dangerous
are
or
dangerous.
is it safe?
No, there are dangers. If you open up a system, as soon as you have a server which has a gate that is open, you have a risk. But as soon as you go outside of the door, you are also at a risk of something that happens. So yeah, there is danger there, but there are also mechanisms to to add security layers there. So I think we should have those layers. So it's not just put it all on the web and everybody has access. I think there needs to be dedicated access based on personal IDs that says, well, I am from the service, I'm the worker from the service company, and I will have to do maintenance activities. Then you get certain access so that you don't have to call somebody and have a printed thing that says you have to potentially add something here, but figure it out on site. So I think this person should have access to that asset via his devices, so that they can get access. I mean, we are so connected to so many things. We are connected to our flights and to our hotels and to our buildings here. Why can't we do that? Or to our bank. I mean, the bank is also online. All our banking information is online, and there is danger. We do lose some from time to time, but there's also mechanisms to reduce risk, and there's really strong people on this. And there are also measures. So we did, in the same project, we did, in this Brains for Buildings project, we did have a working package that was looking specifically at security. And there's also lots of security risk there just with the equipment, with the thermostat, which is from 20 years ago, has no security. That's also that's actually a bigger danger than your servers typically, because nobody expects an attack via the coffee machine, sort to say. So yes, there is dangers, but I do think we are going in a direction, and we should have the appropriate mechanisms in time to secure it.
Okay. Somebody else wants to react? Okay. Well, then, actually, like first, then 3 presentations, it was mostly about, if I just generalize, using data for well-being, improving well-being, or mostly saving energy. And but actually, Peter, you also, in one of your slides, then about that URL of each component, that goes in using data for circularity in buildings. So actually, do you think, is this already happening? It's actually, to me, it looked like sort of a material passport, which...
I think we are getting there. It's more often used for larger resources. So from actually, well, I actually don't know for the systems. I hope it's also circularity in systems. I also think there is. I mean, the first step that you have is a take-back policy that you say, I guarantee you that we will have lighting here for the next so many years, and these are my lights, and I will repair them, and I will take them back when they are broken. I hope you can help me here. I do think that this exists, and if you do this more and more using these URIs, if you know how they're doing individually, then I think that those policies can be done better, because I think, or can be optimized. We don't want to take away lights that are fully functional. We also don't want to take away lights that are completely broken, because then it's too late. So you have to have a decent mechanism there, which I think also exists. I'm looking here to my...
Yeah, Henry, are you using it?
Yeah, I think it's I think one thing what has been discussed very long time already, it's called lighting as a service type of model. However, I have to say that it's not the most common model. So lighting as a service would mean, for example, that indeed you are, or provider is responsible of actually even might own the luminaires there on the site. So that model exists, but it's not very common. So normal thing actually is that kind of the building owner also owns the settings there, and then when demolition or kind of renovation comes, they go in I hope I think lighting actually goes, at least in Europe, quite well through these BEE circulation topic. It has been actually lately, I think last 10, 15 years, it has been that way easy that lighting renovations, they have been quite a lot actually replacing this old technology. It's like fluorescent. So there has been big energy difference that new LED lighting has replaced fluorescent. So it's actually, in that sense, there has been a strong logic that not to reuse even functioning devices because they are using so much more energy. But that actually might be the more problem in the near future when actually these good lighting, let's say energy way, good well-performing LED lighting solutions will need to be renovated at some point. For example, that there is some office renovation generally, and architects wants different kind of luminaires which look nicer color or whatever. There, this circulation comes more topical. So it will be a hot topic, but yeah.
Okay, thank you. Well, then maybe last question to everybody. I will start with Risto. So our expert talk was data-driven smart buildings. So from your actual experience, how is that field evolving? How it's coming, and with actually European policy, EPBD, and where will we be in 10 years? Will there be everywhere like data-driven buildings using energy flexibility? Is that realistic? What do you think?
I think that's a one target for European Commissioning to increase smartness of the building, and SRI is one element for that, but this is a question that what will happen, because in the future the energy production is renewables, so the buildings must be more flexible, and at the moment we are not that level, but I believe that anyhow the markets will handle that, because energy price variation will be so huge that this makes sense to building owners to invest and looking for other solutions there. And of course SRI has problem because it's just a scheme that measure possible services, but it's not exactly make in the test in the field or trust any simulations or whatever. It's just looking for what kind of service levels are available there. But I see that this is the first step of this direction. In the future, maybe we going more like testing and simulation side for that, but we are not at the moment ready for that. And I think it's still possible voluntary in each country to have this scheme. And I think that's now under discussion, like in Finland. I don't know what will happen and what's the result of that. Are we implemented or not? But it's a question that is a new scheme is needed, maybe merge other schemes like the energy certificate, for example, because otherwise it's coming too expensive and too clumsy that how we do it, this kind of thing. But definitely I believe that the smartness have to be increased.
I agree with Risto that we already have now requirements for the automation systems, and SRI as a new method of like promoting smartness in buildings. Those are the starting point, and we really need to also invest in the building operations, since it has a huge impact on the energy use, and make sure that the buildings are like performing as planned. That's quite often that they don't perform as planned, so we need like commissioning services, ongoing commissioning services to make sure that the buildings are actually working as they should.
Yeah, I agree what previous speakers said, but maybe just to add that being in a little bit this building related industry quite long already, I have to say that it's construction business and also this building automation and smart building, we are quite slow. So it means that I at least thought 10 years ago that we are much more totally different place today than we actually are. So progress actually is relatively slow. I hope it will be maybe this hockey stick curve we are entering now to fast development, but it's a direction is clear. And that direction we have been talking today also here. But how fast this will happen in larger scale, I don't know. Earlier I have been quite optimistic and maybe going towards more realism. It's a relatively slow development at the end.
Yeah, I don't have that much more to add. So for regulations, for example, I think that's one thing, but I think we should also try ourselves to advance. And I think There's two difficulties that I see in my mind that could help us if we get beyond them. One of them is the portability of those AI models that Heike was explaining. So you making a machine learning, a reinforcement learning model, it's quite an effort, and then you have it, and then what? So then you have done one system, but what about the next? So I think we should try to make this more portable in a way. I think that's would be a promising thing to do, so that it's actually more effective to do this as a business, as a company, to make those models and use them. And a second thing that I think we should also look at in Europe then is to have infrastructure that allows us to interconnect our data streams. Every building is making their own data infrastructure basically to actually do things that happen everywhere. So if we would have a more of a data ecosystem in Europe, that's something that the European Commission does with those data spaces, for example. I think that would be something that we can then rely on to do a more robust data handling. That's it. Thank you.
Okay, thank you. Are there any more questions from audience? Yes, we have. Okay, then that's last question.
Okay, sorry. I have a question for Peter, Professor Peter. In your presentation, I found I remembered there is a figure like you mentioned. There are two databases. One is like graph-based database, and one is time series database. And I have one question: like, how do you integrate these two data for further control? And another question is, in your conclusion page slide, I think you mentioned don't transform building data into graphs or something like that. I can't remember exactly, but can you explain it a little bit? Thank you.
Yeah, thank you for the question. So for the first question, how do we integrate these databases? It's not a matter of putting one into the other. So they're two next to each other, and the integration happens on a layer higher. And it's not super. I mean, it's not super magical. It's just making sure that you have the correct identifiers in both systems and manage it appropriately as a software developer. That's something that you can do in a number of ways. I try to make it work the workflow a bit lighter. So we're only working here with a number of buildings, so it's not the entire of Netherlands. So depending on your scale, you might want to have a different strategy. But at the moment, we're just using an API on top, and then we connect those databases, and then we send queries from one to the other database. And that's straightforward. You can do it this afternoon, I believe. And then the second question, so don't transform everything into graphs. That's a bit related. So it said, yeah, don't transform everything to RDF graphs. This is a reflex that you have when something works. You think, well, we should use it for everything, but it does not work for everything. So we should have those graphs for our semantics, but both geometry, file images, and these sensor data, which are coming in so often, you don't put them in a graph. They have to be in a more dedicated software. Okay.
Thank you. Well, so I think we are really at the end of our session. So I would like to, on behalf of REHVA, who is organizing this expert talk here at Leiden Building 2024 in Frankfurt, I would like to thank you all, our four speakers. Peter Paulus from Eindhoven University in Technology in Eindhoven, Netherlands. Henry Jussler from REHVA in Finland. Heikki Ihasalo from Granlund and Aalto University in Finland. And Risto Kosonen from also Aalto University in Finland, and he's also Vice President of REHVA. Thank you everybody for coming here, and I hope that now actually we can enjoy lunch and speak further. Thank you very much.